Hi guys, today we're going to talk about root form of quadratic functions. So if you want to pause the video and take out your notes, you probably won't want standard form and vertex form from the last two sets of notes, but you might want the equivalent quadratic forms notes and the analyzing graphs of quadratic functions notes. So if you want to take those out, you are certainly welcome to. What I'd like for you to do now is pause your video and try to fill in as many blanks as you can on the front side of your notes on the first page. So pause your video and try to fill in the blanks. So in root form, we have the a value that appears in the other two forms, but then we have the first root and the second root. There are typically two roots in your quadratic functions. So if you're looking for the vertex, take your two roots, add them together and divide by 2. That's the average, and that'll be like the halfway point between the roots, and that's where you'll find your vertex. So let's say that your roots are, this is just an example, let's say that your roots are 5 and 9. So if I add 5 plus 9, I get 14. And if I divide by 2, I get 7, because 7 is halfway between 5 and 9. So 7 would be the x value of my vertex, and then I would substitute 7 into the equation to find the y value. Remember that your vertex is a location, so you write it as an ordered pair, h comma k. If I'm looking for the axis of symmetry, then I just take the x value of that vertex. Remember, it's also halfway between the roots. That's what we just looked at here with this little example. You write the axis of symmetry as x equals, and then the number that it goes through, that h value. If you're looking for the maximum or minimum, it's the y value of the vertex, so it comes from right here. If that y value is the largest y value in the function, then it's the maximum. And if it's the smallest, then it's the minimum. You always write your maximum or minimum value as y equals and then the value, so that I know that it is a y value that shows how high or low something is. To find the y-intercept, it's always located where x is 0, so you want to substitute 0 in place of x and solve. The y-intercept again is a location, so we write it as an ordered pair, 0, comma, and then the y value. And then finally, for the x-intercepts, they're located where y equals 0. That's what puts them on the x-axis. So you want to substitute 0 in place of y and solve for x. Again, x-intercepts are a location on the graph, so you want to write them as an ordered pair, x, comma, 0. And of course, these x values right here are your solutions, roots, and zeros. So let's go ahead and get to our example. Our example today in root form is y equals -1/4 times x minus 4 times x plus 3. So let's pick out some of the things in our equation first. So I notice we have this right here. What is this? That's the a value. And what does it tell you? Because it's negative, it tells you that the parabola opens down. So that's because a is negative. Whoops, sorry. Okay, what else do we have? The formula says x minus the first root and x minus the second root. So these things that I'm subtracting here, they must be root 1 and root 2. But remember, everything in parentheses is a lie, so whenever I write my roots, and I understand I'm going out of order, but it's just what you can pick out of root form. When I write my roots, I want to write the opposites of what's in parentheses. So the first root comes from the factor x minus 4. Well, the opposite of minus 4 is positive 4. The formula says you subtract the root, so we're subtracting 4. 4 must be the root. The second root is x equals the opposite of this. So if the factor is x plus 3, then the root must be -3. And remember, Everything that is a root is also an x-intercept, a 0, and a solution. So just by picking out the roots from my root form, I can go ahead and fill in all 4 of these things. My x-intercept is a location, so I do write that one a little differently, but the zeros and solutions I write the same as the roots. Okay. So let's go back up to the top. Now that we've picked out the a value and the 2 roots and we've put that information where it belongs, let's go answer the questions that are up at the top. So the vertex is an ordered pair because it's a location. Remember that in root form, your vertex is halfway between the roots. So if you take your roots and you add them and divide by 2, you get the x value of your vertex. So my 2 roots from root form are 4 and -3. So if I have 4 plus -3 and I divide by 2, well, 4 plus -3 is like 4 minus 3, that's 1, over 2, that's 1/2. Very nice. Now that I have the x value, how do I find the y value? Well, I substitute. So I'm going to go ahead and substitute over here because I think it's going to take a little bit more space than what I have down here. So I have y equals -1/2 times x minus 4, so 1/2 minus 4, and then x plus 3, so 1/2 plus 3. Now I know from intermediate school or middle school that whenever I add or subtract fractions, they all have to have the common denominator. And so these denominators are 2. I'm going to do the same thing with my integers. I'm going to make them have a denominator of 2. So I have -1/2 times 1/2 minus 4 over 1 needs to be something over 2. So I'm going to multiply both of these by 2. This is 8 over 2. And then 1/2 plus 3 over 1, well, I want that to be something over 2. So I'm going to multiply both top and bottom by 2. That's 6 over 2. So this is -1/2 times 1 minus 8 is -7 halves. And 1 plus 6 is +7 halves. So when I multiply all of these together, negative times negative is a positive. 1 times 7 times 7 is 49. 2 times 2 times 2 is, ooh, no it's not. This should be, what did I do wrong? What's my a value? -1/4, so this should have been a 4 under here. So 4 times 2 times 2 is 16. So 49/16 is my y value of the vertex. Ooh, not exactly my favorite number, but that's okay. I'll give you a moment to pause your video and try to come up with the axis of symmetry, the maximum, and the y-intercept. Pause your video and try it out. Your axis of symmetry and your maximum come from the vertex. It doesn't matter that they're fractions and not numbers that you might be comfortable with. They still appear in your axis of symmetry, x equals 1/2, and your maximum value, y equals 49/16. And I know it's a maximum value because my graph is supposed to open down. So if it opens down, that vertex is at the top and it is a maximum. Now I also asked you to find the y-intercept, so I kind of started it. The y-intercept is located where x is 0, so how do I find the y value for the y-intercept? I take 0 and I substitute it for x. So y equals -1/4 times 0 minus 4, that's -4. 0 plus 3, that's 3. So y equals -1/4 times -12. And negative times negative is a positive. And 1/4 of 12 is 3. So there is my y-intercept. Let's talk about the increasing and decreasing intervals and the domain and the range. So I'm going to look at my sketch. Remember that your axis of symmetry right through the middle was at x equals 1/2. So everything to the left of 1/2 or less than 1/2 is going to be doing something, and everything to the right of 1/2 is going to be doing something else. So on the left side of 1/2, what's your graph doing? From the left to the right, what's it doing? It's coming up. It's increasing, right? That's all the x values that are to the left of 1/2, that are less than 1/2. That's the increasing interval. So all the x values that are less than 1/2. Now once it hits that vertex, after the axis of symmetry, it turns and it starts going down. So all the x values to the right of 1/2 or greater than 1/2, that's the decreasing interval. The domain from arrow to arrow, left to right, is all real numbers all the time. And then the range has to do with the maximum value. So the maximum value is this fraction right here. It's at the very top. The rest of your graph is either at that fraction or below. So the range is all the y values that are less than or equal to 49/16. Okay. Next thing it asks us for is vertex form and standard form. So I'm going to actually do vertex form first because I feel like I have all of these pieces. Maybe you know you have all the pieces too. So why don't you fill in the a value, h value, and k value and put together vertex form. So pause your video and try putting together vertex form. So your a value is -1/4 from the original equation, and then your vertex was 1/2 and 49/16. So all three of those numbers go in, and here is your vertex form. Check it with yours. Finally, we have standard form. Standard form is definitely going to have the a in there of -1/4, but I have almost like a factored form for my quadratic. And so how might I make this look like this? Well, I would FOIL it, right? I would FOIL it, and then at the end, since this is a fraction, I might wait until the end. I'll distribute that into the parentheses, but I'm going to FOIL this first. So I have y equals -1/4 times, let's FOIL, x times x, x times 3, -4 times x, and -4 times 3. I combine my like terms. So I have x squared, these two together, 3x's minus 4x's make -1x's minus 12. And finally, if you want standard form, you have to put that a value into the parentheses, so you need to distribute. So y equals -1/4 times x squared is -1/4 x squared. -1/4 times -x is positive 1/4 x. And -1/4 times -12, well, negative times negative is a positive, and 1/4 of 12 is 3. And you can kind of double check because remember your c value in standard form is your y-intercept, and we got 3 for our y-intercept here. So this is our standard form. Y equals -1/4 x squared plus 1/4 x plus 3.